Okay, so let's start Unit 2, and we're going to start by factoring. And this is from Algebra 1. If you don't remember it, that's okay. I will teach you again, but hopefully you kind of remember it from doing it before. So first, let's talk about GCF. You've seen GCF many times in elementary school, and what a GCF it stands for is greatest common, can't spell, common factor. Okay, so the greatest common factor. So a factor is something that a number is divisible by. So like this is the long way to do it. I don't expect you to have to do this every time, but let's just list what I mean by factors. So let's talk about 8 and 6. The factors of 8 are 1 and 8, and then 2 and 4. So it's like what divides evenly into the number. And this one for it would be 1 and 6, 2 and 3. Therefore, the GCF, or the greatest common factor, would be 2. Okay, here we go, 9 and 18. You could list them again. I'm not going to. So this has several common factors, like 3, right? I shouldn't say several. There's 2. So 3 is one, but you want the biggest one, and in this case, that would be 9. Okay, 15 and 27, pause it, see if you can do it. On this one, it would actually be 3. Okay, so now the first type of factoring we're going to talk about is called factoring the GCF. So just the GCF, nothing crazy. It does get way crazier. So you first find a GCF that can divide all of the numbers in the expression evenly. Divide each number by that GCF. Write the GCF out front, then put the rest in parentheses. Check your work by using a distributive property. So what's the GCF of 6x and 12? Well, both of them don't have x's, so you can't even worry about that. And it looks like you can divide both of them evenly by 6, right? So since I can divide both of them evenly by 6, I'm going to write that out front of the parentheses. And then now I'm just going to divide it. 6x divided by 6, well, that becomes x. And positive 12 divided by 6 is positive 2. So there it is. You just factored out the GCF. If you were not feeling confident, and this one's pretty straightforward, but they do get harder. If you wanted to distribute it back out to check your work, 6 times x is 6x. 6 times positive 2 is positive 12. Does that match the beginning? Yes, it does. So we did have the right answer. Okay, the next one. Now I have 3 terms. It's okay. Can you factor out an x out of all of them? And the answer is almost, but then this one kind of messes that up. All right, so now we're just looking at the numbers, 5, 15, and 35. I believe the only thing you can factor out is a 5. Oops. So we're going to divide everything by 5. And so I have 5 parentheses, and now we just divide it. Those 5's cancel, and you get x squared. 5x divided by 5 is positive 3x. And negative 35 divided by 5 is negative 7. Okay. Let's do a couple more. So this one looks like you can factor out a 9. So 9 parentheses. Oh, I forgot to write the divide by 9, divide by 9. So this would just give me x squared minus 2. And then, oh my goodness. Let's see, what can I factor out of all of these? Looks like to me a 2. Sometimes you could do a negative 2. Some people will want to do that whenever this leading coefficient is a negative. Usually they like to factor it out. I'm just going to do good old regular 2. So divide by 2 everything. So negative 4x divided, 2 up front. Negative 4x to the 4th divided by 2, that would be negative 2x to the 4th. The next one would be positive 4x to the 3rd. Then the next one would be negative 2 divided by 2 is negative 1. So negative x to the second power. 12 divided by 2 is positive 6. And negative 16 divided by 2 is negative 8. And of course, make sure you close those parentheses. There we are. So that was a pretty ridiculous problem, but it's all right. Okay, now here's actually like legit factoring. That other one is kind of like the easy, like entry level stuff. So now we're going to start getting into the crazy stuff. So you always check all of the terms to see if you can factor out something. Okay, then you find the GCF of the first two numbers and factor it out. Find the GCF of the second two numbers, factor it out, and then what you're left with is kind of your answer. And I'll show you. It looks a little weird, but it's actually kind of cool. Okay, is there anything I can factor out of all of those? I almost thought 2 for a second, but then that 15 kind of ruins that. So doesn't look like it. So then let's just talk about these first two. Okay, disregard the other two terms. What is the GCF of those two terms? Well, it looks like they both have an x squared in it, right? And then 6 and 15, I think you can divide both of those by 3. So we're going to factor out a 3x squared from both of them. Okay, so I'm doing 3x squared. And then I'm going to start my parentheses. 3x to the third divided by, 6x to the third divided by 3x squared would be 2. And then x to the third divided by x squared is x. So remember your rules from Algebra 1. If you have 3 x's on top and 2 on bottom, 2 of them cancel and you're left with just x. Okay, and then minus 15x squared, the x squareds cancel and that would just be minus 5. Good. So now let's do this other problem, or other set. What can I factor out of both of those? Looks like just a 2, right? So I'm going to factor out a positive 2. Oops, let's do it in blue. Okay, and then I have my parentheses. 4x divided by 2 would just be 2x. Negative 10 divided by 2 is negative 5. Okay, so now this next part is huge. In order for you to go any farther, the stuff in parentheses must be the same. Okay? If it's not, you either did something wrong or it's unfactorable, which does pop up sometimes. So just know those two have to be the same. So you're going to take that set of parentheses, one of them, you don't need both, just write one, and we have 2x minus 5. Okay? I just took exactly what's in those shared set of parentheses and wrote it down below. And then, this is where it gets crazy, you take the stuff on the outside of those parentheses and put those in some parentheses. So I have 3x to the second power and a positive 2. Okay? So, that is your answer right there. Boom, we're done. Okay, I know it was kind of crazy. If you wanted to check your work, you could by distributing out or foiling it out. So I'll just do it really fast only for this problem. 2x times 3x squared would be 6x to the third. 2x times positive 2 is positive 4x. I'm going to do the other ones. Negative 5 times 3x squared would be negative 15x squared. And then negative 5 times positive 2 is negative 10. So, as you can see, mine are in a little bit different order because of how I wrote them. But I have the 6x cubed, I have a negative 15x squared, a 4x, and a negative 10. So we did it right. Okay, let's do this next one. Throw some parentheses around it. So So what can I divide 5x cubed and 15x squared? Well, it's 5x squared. Okay, sorry. And then divide this one by 5x squared. And you get, so I'm going to put 5x squared out front. And then we're gonna have 5x cubed divided by 5x squared is just an x. Positive 15x squared divided by 5x squared is positive 3. Okay, same thing over here. This side is usually easier because the numbers are usually less, not always. Divide by 2, right? Because that's all you can factor out, a positive 2. And that gives you x plus 3. Double check that our parentheses are the same. Yes, they are. So I'm going to write the stuff out front this time first. So 5x squared plus 2. And then the stuff inside the parentheses, x plus 3. Right? So that is, let me highlight this so it looks nice for you. So that's where I get all that stuff from. Okay, let's just do a few more. So this one is a little bit trickier. So what can I divide those first two terms by? Okay, so let's see. Positive, oh, sorry, not 3. X squared, it looks like, is it? Right? Because 3 and 5 don't have a GCF besides 1. So this will be x squared times 3 plus 5, or 3x plus 5, my bad. Okay, now, what can I factor out of this next one? Looks like nothing. First glance, looks like nothing. So let's see what happens. If you factor out nothing, it's just like dividing by positive 1. So this would be positive 1 times, and this does happen sometimes, negative 3x divided by 1 is negative 3x. Negative 5 divided by 1 is negative 5. But we have a huge problem. Well, it's not really that huge. We'll fix it. Notice our parentheses. They are super close, except their signs are off, right? These are both positive and these are both negative. So what I need to do, since these ones are positive and this is more difficult to change, let's change the green ones, which will be easier. What can I divide that by to make those signs flip? Well, negative 1, of course. So this is going to end up being, this eraser never wants to work. This is going to end up being, so negative, or factoring out a negative 1. So negative 3x divided by negative 1 is positive 3x. Good. Negative 5 divided by negative 1 is positive 1. So you take what's out front. So I have x squared minus 1 in parentheses. And then take this and you get 3x plus 5 in parentheses. All right, a few more, we're almost done. This one looks like on the first, oops, this is a typo. Make this into the second power. So let's factor out, looks like just an n squared, right? So this would give me n squared times 2n plus 1. This one looks like I can factor out a 3. So divide by 3, it's a positive 3. So this will be 2n plus 1. Perfect. My parentheses match. Therefore, this is n squared plus 3 in parentheses times 2n plus 1 in parentheses. Okay, 2 more to go. Factor out of these first two. It looks like I can factor out a 2n squared. I know I'm going a little bit faster, and this video is getting a little long. So this would be 2n squared out front, parentheses, n, right? Because those 2's would cancel. Plus the n squareds cancel, and you get 5. All right, these ones I can factor out a 2. So positive 2, and that would give me 2n. And positive 5. Okay, so I did something wrong. It's probably, actually, we're gonna leave it like this. So since I did this, sorry, here's another error, but since these parentheses don't match and we did it the correct way, yeah, I think I'm not really sure. We'll just say that this is unfactorable. And that might come up again later. So sometimes that does happen. So whenever it's unfactorable, you just leave it in how they gave it to you. All right, last problem. This time looks like those first two. Let's look at them. A v squared, and then it looks a 3, right? So 3v squared. So this would give me 6v, and this would give me minus 5. Okay, let's look at these ones. It looks like I can factor out a 4. So positive 4, that would give me negative 6v plus 5. Uh-oh, what do you notice? We need to change that 4 to a negative 4 because we want those signs to flip-flop, right? So let's try this again. So since I'm factoring out a negative 4 with a negative sign right there, that becomes positive 6v, the first one. The second one becomes negative 5. Perfect, they match. So I have 3v squared minus 4 quantity to times or multiplied by 6v minus 5. All right, that is it for factoring by grouping. Thanks for watching. Have a great rest of your day.